All right, we are still working on graphing these two different types of functions that are inverses of each other, our exponential and our logarithmic function. And today we're going to be working on graphing the logarithmic functions. We previously looked at the exponentials, so we know that the nature of those is either this increasing or decreasing values, and we have a horizontal asymptote. Well, things are going to change when we have a logarithmic because we are looking at an inverse, so things get swapped around. Let's go ahead and get started. So the first thing we are going to line up with is what happens for each of these. In our exponential graph that typically looks like this. This is our increasing graph, and we do have the decreasing graph when we have our base be between 0 and 1. Okay, but for these, our domain is all real numbers. There's absolutely no restriction on what value you can put into the exponent, a positive, a negative, a 0, a decimal, whatever. Now my range was based on my asymptote, and my asymptote was a horizontal line that was determined by a vertical shift. So did it move up or down, or did it stay the same? But it was always y equals a number. That's the horizontal line. And that was going to be my asymptote to infinity, is where we got our range. My y-intercept always came from substituting x equals 0. And that meant we could often find it in the calculator, so we had 0 comma something. Okay? My logarithmic graph, knowing that it is an inverse, okay, and that means that it's going to reflect over the axis. So let me, axis of y equals x. So here's our y equals x line, that it's going to reflect over that. It's going to look something like this. Okay, and that means that my domain is going to be limited because my asymptote is going to switch. So let me explain that my domain and range are going to switch. So my range is all real numbers. My domain is based on the asymptote to infinity. Well, my asymptote is now going to be a vertical line. Okay, and that is determined not by the vertical shift, but this time by the left or right. So by the horizontal shift. And it's going to be an x equals. So it should be no surprise that if the range is what's affected by the asymptote, it has to be a y equals. But if the domain is affected by the asymptote, then it has to be an x equals, because domain is for x and range goes with y. All right, now this time we're not going to be looking for an y-intercept, we're going to be looking for an x-intercept. And we will find that by setting the y equal to 0. So we're substituting in y equals 0. When will this be a 0 is basically the question. So let's go ahead and get started. We're going to take a look at a very basic logarithmic graph. That is log base a of x. So there's no actual given base here, I just have a general shape. What you can see is that my domain is restricted because I have my vertical asymptote right here on my y-axis. So I'm going to start with the asymptote and say that's what's obvious to me, is that it doesn't cross this axis, our y-axis, which means that my domain goes from 0 to infinity. There's nothing else. So those are very much connected. My range, it looks like if this graph goes on forever, it's going to get higher and higher very slowly. And then over here, it's still going to continue down and go to infinity. So my range is all real numbers. To find my x-intercept, I'm looking for where it crosses the x-axis. This means if I want to find out where something crosses the x-axis, then I'm going to set it equal. I'm not substituting 0, I'm setting it equal to 0. So 0 equals log base a of x. That means that a to the 0 power equals the x-intercept. Oh, well, anything to the 0 power is 1. And so that would be 1 comma 0 if it doesn't shift at all. So this would be very simple if it doesn't shift. Let's go ahead and grab your calculator and give these a try. But before we do that, and it's important that you have your calculator on and open, ready to go, I want you to go into the y equals. So you have everything cleared out. You should have no y equal values. It's just your screen. And if you have an older operating system, and you should know if you've got an older or new one by now, if you've got an old operating system, you need to use our change of base that we talked about a few days ago. in order to enter this. So you would be typing in y1 log x slash log 3. Now, if it opens any sort of parentheses, which some do and some do not, you must close the parentheses. Then you would type plus 1. So go ahead and type that. It'd be just log x, close the parentheses if they open, divided by log 3, and close those parentheses. Then you're doing plus 1. Well, how do you know that 1 isn't included? Because if it was supposed to be included, it would look like this. So then we can enter this one. This one would be entered log, parentheses open, x minus 3 slash log, parentheses open, 3, then a plus 2. This is for the old operating system. Actually, anybody can use this method. If you have the new operating system and you want it to be pretty and you want it to actually look like it does here on the screen and on your paper, then you get to use the alpha y. So you press alpha y equals, but you have to arrow to the right where it says FUNC. That's for function. And you will see one that is called log base. And when you enter log base, it does give you the pretty print of putting a 3 in the base and the x in parentheses, and then you arrow over to do the plus 1. Yours will look identical to this. So it's where it says log and then capital letters BASE. And that's the pretty way of writing this. So yours is, if you have the new operating system, it looks a lot prettier. Anybody can use the old operating system method. Refer to this as we continue to enter these in our calculator. We're going to get started now. Here's our first example. So I'm going to let you pause the video. I want you to type that into the calculator, and I want you to get a table of values and graph the table of values. When you press pause to resume the video, I will already have a table done and I will have a graph graphed. Go ahead. Alright, so I have my table of values and I've chosen some values. I noticed that everything from 0 and into the negatives had an error, and that's indicating to me that those values are not a part of my domain. They're part of the restricted values, which indicates to me that there must be an asymptote at 0. So the 0 where the error first begins is where my asymptote is. So that tells me that's my domain, from 0 to infinity. My range is all real numbers, and like I said, x equals 0 is my asymptote. Please notice that I did include an arrow on both ends, and when you look at the picture of this, it kind of looks like it just stops close to the origin. It does not. It's just the pixelation. If you were to change your window and zoom in really close to that, you would be able to see more. And eventually it would look like it was stopped because it starts to graph a vertical line, and a vertical line isn't a function. It's not technically a vertical line, but it just appears that way on your graphing calculator screen because the values are so close together. My x-intercept, I would have to decide where this crosses the x-axis, which happens somewhere between 0 and 1. So I know it's going to be a small number. So to do this, I'm going to set it equal to 0. And I'm going to subtract 3 to the other side. And I'm going to convert this by saying 2 to the negative third power equals my x-intercept. Okay, and that was by taking the base and the power. Remember, p equals log base b of the value. So the value I'm looking for is my x value, my x-intercept. So the base to the power of 3, which means it's at 1/8, comma 0, because my y value is the 0. So that's where it actually crosses. This is a method that you have to use to find the x-intercept. Let's try another one. This time the x plus 3 is in parentheses, and let's see what that does to our graph. So again, I want you to pause, put it into the graphing calculator, and if when you come back your table doesn't match, it's probably because you entered it into the y equals wrong, so go back and check that. And then refer back to that previous screen where I explained the different methods of entering it. But so when you come back and resume the video, you need to have a table and you need to have the graph done, and then we'll get the information together. Go ahead. Okay, so this one we can see that that plus 3 actually moved it over to the left, which gave us some more information, but I can see that it definitely made a shift. And I can see my asymptote very clearly at x equals -3, which dictates my domain to be from -3 to infinity, exclusive. That's why the error is there. It's not included because that's where the error is. That's where the asymptote is located. My range is all real numbers. Also notice that the values that I chose to graph didn't have to be all those decimals. In fact, within the range of what I was plotting, I could definitely pick off some nice numbers. 5,3 is awesome. I could have also scrolled a little bit further and I would have found that 13,4 was decent, but that didn't really fit on my graph. So you don't have to always use decimals just because they're the ones that are consecutive. Okay, my x-intercept happened to show up really nicely this time in my table of values, and that would be -2, 0. Now if I wanted to find the y-intercept, and just being prepared to be able to find that, y-intercept would mean that I would want to plug in a 0. So if I plug in a 0, I end up getting 0 plus 3. So here I'm saying 2 to what power is going to equal 3. And that I would actually just have to type in and evaluate log base 2 of 3 using the change of base formula. So that's something we could do. So if you go to your home screen, you're going to use either the fancy type for the log base, or you're going to do log 3 parentheses divided by log 2, and you make sure you have parentheses around the 2 and the 3. And that tells me that my y-intercept is at 0, 1.585. I'm just going to round there. And that seems to be about where it is, right between 1 and 2. All right, good job. Let's keep going. Okay, so the next one is the natural log. And if you can imagine, since the natural log is an automatic base e, that when we graphed our exponentials that had a base of e, none of the values turned out very pretty. So we are going to get decimals for almost every single spot here. In fact, there's probably likely only one place that we won't get a decimal, and that's because we have the 0 in there. So go ahead, and again, I want you to just type in natural log of x. It's exactly how you type it, and I want you to get a table and get the graph, and then return, and we'll get the information together. So go ahead and pause now. All right, so here we are. Now I have a table of values, which I saw that the 0 was where the start of the errors were, which means that those are unacceptable values in my domain. So from 0 to infinity work, which means my asymptote is at x equals 0. My range is all real numbers. There's no values for y that I won't be able to get because these do get really, really small down here. And my x-intercept showed up really nicely in my table of values. I will not have a y-intercept because the asymptote is on my y-axis, so I won't be able to actually get there. So no worries about a y-intercept. We've got one more example, and that's going to be a natural log with a transformation. Go ahead and type this in, get a table of values, and put your points on there, and then come back and we'll check to see that we got the same thing. All right, here we go. So in this case, you can see that the -1, which is a shift to the right 1, actually created where our asymptote was going to be located. I think it's very valuable to put your asymptote on the graph so that you can see that this doesn't accidentally, I'm going to draw this extreme line here, that it doesn't accidentally just whoosh go over there when it's not supposed to cross. So having so let me erase that line. Having this value, or the asymptote drawn, will keep my values where they belong on my graph. I also noticed, for me, that it has one really nice point, which was 2, 2, and the others were decimals, but there wasn't a lot of growth between 4 and 9 in my table of values. So my x value of 4 was, oh, did I copy that wrong? I did. I was thinking, wow, it didn't grow very much. So this one should be about here. So it should grow a little bit more than that. Just barely over 3 to just barely over 4. 309. There we go. That's better. So I'll erase the bad one here. Actually, let's erase all of that. Let's get that on there better. I want to give you the best graph we can get here. So 43098 and it goes like this. But there really wasn't a lot of growth. This one between 4 and 9, it only grew less than 1 whole unit in all of that span. But that's just the nature of this graph. So domain from 1 to infinity based on where my asymptote is located. My range is all real numbers. And my x-intercept on this one, I'm going to have to do a little bit of work. So let's do it together. So we have 0 equals the natural log of x minus 1 plus 2. We're going to subtract 2 to the other side, and I get the natural log of x minus 1. Since natural log actually has a base of, I'm going to write it as a base of e because that way we can use our method from before. We're saying that my base is e, my power is -2, and it equals x minus 1. I can actually calculate this value. I can calculate e to the -2nd power. So go to your home screen of your calculator and just calculate e to the power of -2. It will be an uncomfortable decimal. And then, because I've got this -1, I'm just going to add 1 to the other side. So my x-intercept is 1.135, 0. And that looks about where it is, just past 1. Okay, we can go through that again if you're stuck in how I got from here to here. But I'm just using, remember, I'm using power equals log, base, and value. So my base is e, my power is -2, and it's going to equal the value. Alrighty, please take notes and let me know if you need any help when we see each other next.